Hi, my name is Thaqif bin Jaafar. I'll be presenting our IDP project with a title of Design and Development of a Prototype Tabletop Test Rig of a DC Motor Speed Control Circuit. First of all, what is DC motor? DC motor is a direct current motor converts electrical energy into mechanical energy and is powered by direct current. This causes a rotational change in the device, allowing power to be delivered to a variety of applications across many domains. A stator, an armature, a rotor, and a commutator with brushes are the essential components of a DC motor. In a mechanical system, speed Speed fluctuates depending on the number of activities, and it is required to control speed in order to perform proper mechanical work. Controlling the speed of a DC motor is essential for getting the most out of the machine or tool. Rotational speed of motor and machinery is influenced by speed control. To adjust the speed of a DC motor, three methods can be used. Changing the flux and current through field winding, changing the armature voltage and armature resistance, and finally changing the supply voltage. The armature control method is the most dependable, cost-effective, and load-independent way for controlling DC motor. The back EMF of a DC motor is exactly proportional to its speed, and the speed is directly proportional to armature current when supply voltage and armature resistance are kept constant. This armature control method is based on the notion that by adjusting the voltage across the needed voltage, the back EMF and the speed can be adjusted, which can be done by connecting a variable resistor in the series with the armature, which is the rheostat. Improvisation has been made based on this method, which provides a new strategy in preventing the armature control method, which is controlling the armature resistance control the voltage drop across the armature in which the variable resistor, which is the rheostat, was utilized. The new method involves replacing rheostat variable resistor with a potentiometer and adding a MOSFET transistor. Next, I will talk about the problem statement for this test rig. So, the most commonly debated in speed controller is the efficiency and dependability. The factor of efficiency is crucial in order to save money. The speed control efficiency is influenced by the method control system. The speed controller is usually in charge of the analog system. Analog signals have infinite resolution in both time and amplitude. Next, one of the most common ways to drive a DC motor is through PWM signal in relation to the motor input voltage. A manual controller is also unsuitable in this modern age because it wastes time and money. The cost of controller operating has piqued the industrial sector interest. Because it is portable, we recommend designing a computer-based controller to save money and time. The user can monitor their system from afar, removing the need to visit the machine, which is very valuable in industrial setting. As a result, personnel can be reduced and computers which are more precise and reliable can be employed instead. So, for this project, we focus to achieve the study goal, which is to use tools like MATLAB Simulink to design and create a prototype tabletop rig of a DC motor speed control circuit. The objective also needed to be met, such as following, which are to provide the design and development of a DC motor with a speed control function, and to determine and analyze the production of a torque speed in terms of RPM and efficiency of the DC motor in the control circuit. After that, for the methodology, we use the approach serve as the foundation for this section of the paper, and it will steer the project route. This project took 14 weeks to design and create a prototype tabletop rig DC motor speed control circuit, which is included numerous electrical circuit design component as well as component assisted design to complete the prototype visual. The following are the project procedure and flowchart. The first several sessions of the project were held like to discuss and compile a collection of ideas that match the theme of the semester project overview, to examine the speed control function, a background investigation on the subject of the design and component selection of the DC motor was conducted. Following the creation of the work, a simulation and data analysis were performed after defining the proposed circuit architecture, the necessary parameter results were then entered in a report form, which was subsequently documented for future use along with a thorough presentation of the project. Next, I will proceed to the flowchart for this project. As you can see, this is the flowchart for the project design. First, we start with the discussion about the project with the teammates and brainstorming idea for the project. The design and analysis were done. If it's suitable, MATLAB Simulink and Simscape development were used to create a prototype tabletop rig of the DC motor speed control circuit. If it's not suitable, design and analysis will be repeated again. After that, MATLAB Simulink simulation were done, and if it passed, it will proceed to the virtual prototype development and the prototype will be tested. After finishing the test, the report can be rewritten and finally presentation with teammates will be done. The project flowchart was used to direct the project route with various parameters utilized to determine the suitability of a design during its early stages. After a decision has been reached, the simulation will be designed using MATLAB Simulink and the result will be examined to see whether they are acceptable in a real-world setting run through. The virtual prototype will be constructed once the results satisfy the optimal numbers. As a summary, our team will create a tabletop test rig for a DC motor speed control circuit for this project. When it comes to DC motor and the DC power supply, we shall evaluate a variety of components. The use of a variety of simulation software including Proteus, every circuit, and MATLAB Simulink to determine the anticipated outcome of the various factors and how they affect the DC speed control circuit.
Thank you for the very wonderful presentation, Mr. Thaqif. Hello, my name is Elmindreda Chung, and now I'll be presenting a little bit on the background and then proceed to the procedure to design a DC motor speed control circuit using MATLAB Simscape. Without further ado, let's head into the background. First and foremost, we discuss on this design term for a basic DC motor speed control circuit and then the known controlling methods. And a DC motor speed control circuit must have a DC motor, a potentiometer, MOSFET, either N-channel or P-channel, a DC power source or resistor. Each of these components must be suitable in the circuit. The known controlling methods using motors are shunt motor and series motor by using the armature or field control method in both motors. For this project, we have component selections to select the suitable DC power supply and DC motor types. For DC power supply, we have at least 3 power supplies: the constant voltage current supply, battery eliminator which acts as substitute for batteries, and multiple output supply having a fixed voltage output. And lastly, we have DC motor types. At least we have 4 listed here. PMDC motor, which is a permanent magnet DC motor, series motor and shunt motor, which were previously mentioned, and compound motor. For this project, we use the permanent magnet DC motor. Let's head into the methodology of this presentation. So as you can see, this is the overview for the circuit construction using MATLAB Simscape. The first procedure is to set the DC power supply to 20 volts, in which it's connected to the potentiometer R1, where the wiper has its initial position at 10% and has a maximum resistance of 100 kilo ohms. There must be a ground connected to this circuit and also a voltmeter connected to the potentiometer. Next is the resistor R2, which has also an emitter connected to the resistor. This is the source, power source. This is connected to the gate terminal of the MOSFET, and this is the potentiometer. Next, we see the MOSFET N-channel, as indicated by the symbol here. The drain terminal is connected to the emitter, which is also connected to the DC motor over here, and the gate channel is here, source is here. As you can see, this is the DC motor. The DC motor has a rated voltage of 10 volts and a 900 rotation per minute of no load speed, and we annotate this as M1 for DC motor. The DC motor has connected to the voltmeter, and then connected to this ideal rotational motion sensor, in which in real lab environment situation is a tachometer to let us preview the rotation per minute of the DC motor. And that is the description for the circuit, in which the results of the emitter and voltmeter can be dragged here. It's indicated by the red wires here. And that is all from me. Thank you.
For the electrical simulation, we are using MATLAB Simulink and Simscape. We have the direct current voltage source, the potentiometer, MOSFET, and also the DC motor. And in this circuit, there are a few current and also voltage sensor. And if you can see on the right and the bottom part here, this is the output value display. Supposedly, when the potentiometer is adjusted, it will create a varying potential difference across the gate of the MOSFET, and the source pin of the MOSFET will simply follow the value of this potential difference and adjust the voltage across the motor. So supposedly, if we adjust the potentiometer, DC motor speed will also vary. And this is the result for the 10% wiper position. The RPM for the DC motor is around 220 rotational per minute. And if we increase the wiper position to, let's say, 90%, when the wiper position are set into a higher position, that is 90%, the rotational per minute will be higher than the 10% wiper position. In terms of dynamic analysis, we've done a DC motor rotating shaft natural frequency analysis on SolidWorks. Okay, and this is some of the result from different mode level of frequency, mode 1, mode 2 until mode 5. The mode shape and natural frequency value give the direction in which external frequency should be applied, and the allowable excitation frequency can be applied. But generally, external frequency cannot be controlled, so we need to alter the natural frequency of the component itself by varying its mass, its stiffness, its type of material.
Hello, Assalamualaikum, and good day to our evaluator. My name is Junior Sunraj Kumar bin Aladin with metric number of BK18110048. I'm one of the group member of C1 Sasageyo, and I'll be presenting my part now. So without wasting any time, let's go. So I'll be discussing about the mathematical analysis in DC motor circuit for our project, which is the DC motor speed control. But before that, let's have a quick look for our circuit layout, which we have used the software of MATLAB Simscape for this. And what we have is the DC source, resistor, potentiometer, N-channel MOSFET, some voltmeter and ammeter for the readings, and lastly the DC motor, which is the type that we have chosen is the permanent magnet DC motor type. This is the recorded and calculated data that we have obtained through the simulation, and the wiper position is for the potentiometer. Voltage 1 is the voltage across the resistance, while voltage 2 is where the voltage supplied to the DC motor. Current 1 is the current across the resistor, and current 2 is where the current flow through the N-channel MOSFET. Based on the data we have gained, we have plotted some graph, and what we have here is the graph of current against wiper position, graph of voltage against wiper position. We also have graph of rotational speed against wiper position, And we are also plotted the graph of power against torque and graph of power against angular velocity. So, based on our simulation and findings, what we can conclude is that the potentiometer affects the performance of the DC motor circuit. How? Let me explain. The potentiometer acts as a voltage divider. And as you can see, as the position of the wiper, it helps in determining the output voltage and itself affects the speed of the DC motor. From the result and the graph I have shown, when we increase the wiper position by increment of 10%, the voltage source, or we label it as voltage 1, started to decrease. But for voltage 2, which is the voltage supplied to the DC motor, increases. Same goes to the current 1, which is the current flow through the resistor, and current 2, which is the current flow through the N-channel MOSFET, increases. So the potentiometer, it acts as a variable resistor, where when we alter the wiper position, it indirectly reduces the resistance of the circuit, thus making the voltage source depleted. And what we can say that this circuit obeys the Ohm's law. Why? Because when the resistance of the circuit decreases, the voltage also started to decrease, but the current flow will started to increase. So the voltage source and current flow to the resistor affect by the changing of the wiper position. As for the N-channel MOSFET, it is only affected by the voltage source, and based on the voltage source, it will affect the value of voltage supplied to the DC motor and current flow to the N MOSFET channel. Lastly, based on the graph we have plotted, which is the graph of power against torque and also graph of power against angular velocity, we can say that these three functions are closely related. Torque is the rotational equivalence of linear force, while power is work done in a time interval. We can say that the relation between torque and power is directly proportional to each other. We can say that the power of a rotating object can be mathematically written as the scalar product of torque and also angular velocity. And we can say that the power is affected by potentiometer. How? Because power is affected from both current and voltage, while the rotating speed is the responding variable from the value of power. As the potentiometer is capable in varying the resistance, the value of the resistance affect all three values of the power, rotational speed, and also the angular velocity. So that's all from me.